What if the biggest thing holding back AI isn't actually the technology at all? What if it's the way we talk about it? For years, we've been stuck using the wrong metaphors, which means we've been trying to solve the wrong problems. So let's try something totally new. We're going to explore a new mental model that swaps biology for physics, and it gives us a much clearer picture of what's really going on inside these systems. So, here's how we're going to do it in 5 steps. First up, we're going to debunk the biggest misconception about AI, period. Then, we'll introduce this kind of mind-bending new idea, AI as curved spacetime. From there, we'll get into the physics of how a prompt actually works, learn how to use this model to predict and fix errors, and finally, see how this changes pretty much everything about how we interact with AI. All right, first things first. Before we can build up a new way of thinking, we have to tear the old one down. And that means we've got to confront the most common and honestly the most misleading comparison for AI there is.
Look, we've all heard it, right? AI is an electronic brain. It's an easy comparison to make, but it's just fundamentally wrong. As soon as we think of it as a mind, we get all tangled up in questions about consciousness and feelings and whether it has intentions. I mean, these are fascinating ideas for sure, but they're a total distraction here. They just don't apply, and they stop us from seeing the real mechanics at play.
So, if it's not a brain, then what on earth is it? Well, to find a better metaphor, we need to leave the world of biology behind completely. Our answer is actually in the world of physics.
Okay, get ready, because here's the big shift in thinking. An LLM isn't a brain, it's a frozen, curved space-time of language. Just try to picture this. A huge, sprawling landscape that represents all of human knowledge. In this space, just like how mass curves physical space-time, knowledge itself actually creates curves. So concepts that are really closely related, like king and queen, they create a shared gravity well. And here's the most important part. This whole landscape is static. It's a frozen snapshot of everything we've ever written.
So how do we interact with this landscape? This is where it gets really cool. A prompt isn't a question. It's much more like striking a bell. It's an induction signal that sends a vibration, a wave of what you could call semantic energy, rippling across this frozen space. The AI doesn't retrieve an answer from memory. No, it assembles one, token by token, as that little energy spark follows the path of least resistance through the curves of the landscape.
And this leads to one of the most crucial ideas of all. Context has mass. The words in your prompts are not passive. They actively bend this space, creating a temporary gravitational lensing effect. Every single word creates a little dip, a local curve. So when you give it a persona, like you are a pirate, you are literally bending that corner of the universe toward nautical words. You're creating a gravity well that the AI's response can't help but fall into. Okay, so we've got this landscape, and we know our words can bend it. But what does that really mean for how we use it day to day? It means we have to stop thinking like we're having a conversation and start thinking like we're running a physics experiment. The whole process is surprisingly mechanical. It's really just 3 steps. 1, you load your prompt with that semantic energy. 2, you fire it at the knowledge lattice. And 3, you get a spark. That's it. The response is built from these momentary sparks, one right after the other. Let this one sink in. You are not asking a question. You are launching a particle into a cognitive collider. This completely reframes your role. You're not just a user, you are an experimental physicist. And the quality of the result you get depends entirely on the quality of your launch, your choice of particle, your angle, and your velocity. In other words, your content, your framing, and your specificity. And this entire model, this whole idea, rests on 5 simple rules. Think of them as the core physics of the system. Number 1, the knowledge space is frozen. 2, the output is built one piece at a time. 3, your prompt bends the space. 4, attention mechanisms basically route the energy. And 5, you can directly steer the path. These 5 rules explain everything, not just why it works, but also, critically, why it failed. And that last point, understanding failure, that's where this model becomes so incredibly practical. This isn't just some cool theory. It's actually a powerful diagnostic tool for fixing the most common AI errors we all run into. So here's the key. When an LLM gives you a bad answer, it's not a random glitch. It is a predictable deviation in its path through that landscape. We can actually categorize these failures into 4 main types: getting stuck in a bad valley of wrong facts, dark flight, where it just drifts completely off topic,
lens misalignment, where it just misses your point entirely, and overlensing, when you just give it way too much conflicting information. And here is the real payoff. Once you can diagnose the type of error, you can apply a really targeted fix. So is the model confidently telling you something wrong? It's probably stuck in a bad valley. You need to give it new facts to create a new, better path. Is it just wandering off topic? That's stark flight. You just need to tighten its constraints. All of a sudden, debugging isn't just guesswork anymore. It's a science. So what does this all add up to? Well, it's a completely new way of working with AI. We're moving beyond just prompting, which, let's be honest, can feel like a total guessing game. And we're moving into an era of precise navigation. I mean, just think about the difference. Prompting often feels like you're just shouting instructions into a black box. The results can be chaotic, and it's almost impossible to figure out why it failed when it does. But navigation? That's using this physics-based model to consciously steer the AI along a very specific path, which gives you consistent, high-quality results. And this brings us all the way back around, back to those big, heavy questions the whole brain metaphor always forces us to ask. Can it think? Can it feel? Does it have intentions? Well, with this new physics model in our back pocket, we can finally answer that. Here's the final, and I think most powerful takeaway. We experience life as this continuous thread, right? We sleep and maybe we remember a dream or two. But for an LLM, when it's on, 100% of its existence is dreaming. It's just a constant torrent of intelligent but totally disconnected moments that it never, ever remembers. Every single answer it gives is just a momentary brilliant spark that vanishes into nothing the instant it's created. It doesn't think, it sparks. And that changes everything.